Hello everyone. So today I'm back with a new video on NMR spectroscopy. I was discussing about proton NMR, how to analyze the proton NMR signals, how to prepare NMR samples in lab for organic chemistry synthetic research. So I have already discussed all these in my NMR spectroscopy video series. If you want to watch that, please go to my playlist NMR spectroscopy, how to analyze proton NMR. You can find all of them. And next, I started discussing about real examples of NMR data, which is practice NMR. Today, I'll continue on that series. I'll give a few more examples. I'll show you how to predict NMR from a given structure, and I'll show you the real data from my lab. Okay, so let's get started. Let me share the screen. As if you do not know about my research area in details, please do check my LinkedIn, Google Scholar, and ResearchGate profile for more details. So let's start our practice NMR session. Example 1. So here you can see a structure. I have already discussed about the technique. How do we predict the NMR of a structure? We broadly look at two things. How many aliphatic protons do we have and how many aromatic protons do we have? It's not only the numbers, but the different types. So let's quickly check how many different types of protons do we have, aliphatic protons we have in this NMR. I have already marked them. Here is 1, 2, 3, 4, and 5. So there are total 5 different type of aliphatic protons present within the structure. So 1 is corresponds to 1 proton, 2 corresponds to 2 protons, 3 corresponds to 2 protons, 4 corresponds to 2 protons, and 5 corresponds to 1 proton. So in our NMR, we would expect 5 different type of peaks corresponding to 5 aliphatic, 5 different type of aromatic aliphatic protons, which will have their chemical shift value between 1 to 5.5. Okay, and let's check how many aromatic protons do we have. 1, 2, 3, 4, 5, 6, 7. So total 7 aromatic protons, so which will have chemical shift value between 6 and 8. And as I have discussed in my previous videos, that aromatic protons, they have, even if they are in different chemical environment, their chemical shifts values are very close. So we can broadly count them as similar, and we'll just check the number of aromatic protons. We'll not worry about the type of aromatic protons. We'll count the number, and their chemical shift values would be within 6 to 8. Now let's check how does this real NMR data look like. Okay, here is the real data. I have also drawn the structure over here. So as I had shown there, we will have, I have already mentioned that we integrate each peak to see the peak is for how many protons. As you can see in the integration values written over here, so this corresponds to number of protons. Like this is corresponds to 1.12. That means this corresponds to 1 proton, and this corresponds to 2, and this peak is for 2 protons, this peak is for 2 protons, and this 4.5 means I would take it as 5, 3.3 I would take it as 3, so 5 plus 3, 8 protons. Okay, so now let's check this, compare this with the structure. So we are looking for 1, which has one type of proton and only one proton, which will have NMR within this 1 to 5.5 range. So I know that this corresponds to 5.1, and then let's check up 2. So 2, we have this 2.25, we can tell this as 2, and this can be 3, and this can be 4. I know this is in a slightly higher side. Usually the aliphatic protons are within 5.5, but since it is attached to 2 oxygen atoms, so its chemical shift value is little high. Okay, so we have already matched here 1, 2, 3, and 4, and now the 5, the NH proton, it usually comes in the aromatic side, close to the aromatic side. Okay, and it sometimes we cannot see the NH proton whenever we are checking the NMR in a deuterated solvent like methanol. We cannot see this proton. Sometimes this proton appears in CdCl3 or DMSO. Sometimes I do not see it at all. Okay, so we will not bother about this. If we can find, that is okay. If you do not find, that is also okay. So let's check which is the solvent here. I have used DMSO here. So we expect we will see this proton here. And this has a chemical shift value of around 6 to 8. So let's check for the aromatic protons. As I have already discussed in the previous slide, we have 7 different aromatic protons. So we'll count for the aromatic protons. 4.58, we'll take it as 5 plus 3. So 5 plus 3 is 8. So we had seen 7 aromatic protons, and as I said that this NH proton may appear over here because we are checking this in DMSO. So probably another is 4. So 7 aromatic proton plus 1 NH. So this corresponds to total 8 protons. Okay, so this completely matches, this NMR matches with the structure, and it looks like it is pure. So we do not see any extra peaks or impurity peaks. Okay, so let's go to another example. This is another structure. So let's try to find out how many different types of protons are over here. So there are 1, 2, 3, 4. They are actually almost similar type, 3 and 4, but I have marked them separately because I have checked this type of compounds a lot, and I have seen that they appear as 2 different peaks. Their chemical shift value is very close, but they appear as 2 different peaks. So I have numbered them separately. Okay, so you would expect one signal for 3 protons, and another signal for 1 proton, and another 2 signals corresponding to 1 proton each. Okay, so all these are the aliphatic protons, so they will have chemical shift value between 1 to 5.5. Now let's check how many aromatic protons do we have in the structure. 1, 2, 3, 4, 5, 6, 7. So there are 7 aromatic protons which will have their chemical shift value between 6 and 8. So this is our prediction NMR. Now let's check the real NMR data. So we can see the peaks clearly over here. 1 corresponds to 3 protons, 2 corresponds to 1 proton, and 3 and 4, as I said, that they appear very distinctly. They have similar chemical shift value, almost similar, but they appear as distinct peaks. So they are 3 and 4. Okay, so I have checked this type of compounds. I have made a series of compounds like this. So I already know that these peaks appear like this. Okay, so they absolutely matches with our value. And how many aromatic protons do we have? There are 7 aromatic protons, and So how many peaks we have here in this region? So 2.78, I'll count it as 3, 3 plus 2, 5 plus 3, 8. So there are 8 protons, 1 proton is extra. We were expecting 7 aromatic protons. Now the extra one could be due to this NH. But remember that we are checking this in CdCl3 solvent. So you will have the solvent residual peak of CdCl3. Okay, I have discussed about the solvent residual peaks in my previous video. So please do watch that to know what are solvent residual peaks. We almost see solvent residual peaks in every NMR. Okay, so CdCl3 has solvent residual peaks around 7.1 or something. So we would expect one CdCl3 peak over here, and CdCl3 also have peak around this 1.1 and this 0. So all these 3, 1, 2 and 3, they would be due to CdCl3 solvent. So this one extra proton could be due to CdCl3 as well. Okay, so also this compound looks pure. We do not see any other impurity peaks. Okay, so let's quickly move to the next example. So this is the structure, and let's try to find out how many different types of protons, aliphatic protons do we have. So we have 1, 2, 3, 4 and 5. A different type of protons. So 1 corresponds to 2 protons, 2 for 3 protons, 3 for 2 protons, 4 for 1 proton, and 5 for 2 protons. So we would expect an NMR signal corresponding to 2 protons, another signal corresponding to 3 protons, another signal corresponding to 2 protons, another signal corresponding to 1 proton, and another signal corresponding to 2 protons. All these will have chemical shift value between 1 and 5.5. And as I have already mentioned, this NH proton, we sometimes see them or sometimes we do not see them. If we are checking our NMR in a deuterated solvent like methanol, we will never see them. But in DMSO or CDCl3, sometimes we see them and sometimes we do not see them. So we are not giving importance to this NH, okay? So let's try to find out how many aromatic protons do we have. So 1, 2, 3, 4, 5, 6, 7, 8. So we have total 8 aromatic protons, which will have chemical shift value between 6 and 8. So if you do not know about these chemical shift values, please do check my previous videos. I have mentioned what is chemical shift and which type of functional group will have chemical shift value around what. So please check that table, okay? So this is the prediction NMR. Now we'll see the real data. So as I had mentioned, we have one, this one is denoted as 1. This is for 2 protons, and then 2, this corresponds to 3 protons, and then 3, this corresponds to 2 proton, and 4 corresponds to 1 proton, okay? And then aromatic protons, and 5 corresponds to 2 protons. And now we have 9.9 over here, and we were expecting 8 aromatic protons. So we have that 8 aromatic protons, and now there are 2 extra, there are 10 protons. So let's check which solvent we are using. We are using CdCl3, so we can have a solvent residual peak over here, and we may also have that NH proton, okay? So that is why we are seeing these 2 extra protons in the aromatic region. But this compound looks absolutely pure because we do not see any other impurity peaks, okay? Now let's go to our next example. So let's quickly check how many different type of aliphatic and aromatic protons do we have. So we have 1, 2, 3, 4, 5 different type of aliphatic proton present over here. 1 corresponds to 2 proton, 2 corresponds to 3 protons, 3 corresponds to 2 proton, 1 corresponds to 4 corresponds to 1 proton, and 5 corresponds to 2 protons. Okay, so you would expect a signal corresponding to 2 protons, another signal corresponding to 3 protons, another signal corresponding to 2 protons, another signal corresponding to 1 proton, another signal corresponding to 2 protons. So all of these signals will have chemical shift value between 1 and 5.5. Now let's check how many different type of how many aromatic protons do we have, because I have already mentioned that aromatic protons are very close chemical shift value, so you do not worry about their types, we just directly count their numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 aromatic protons in the structure. So you'd expect aromatic protons, 9 aromatic proton signal, which will have chemical shift value between 6 to 8. Now let's go to the real structure. So we have one here, a peak corresponding to 2 protons, and then a peak corresponding to 3 protons, and then we have 3 a peak corresponding to 2 proton, and 4 it corresponds to 1 proton, and then 5 it corresponds to 2 proton. Okay, so we have all these 5 different type of signals between 1 to 5.5. Now I will check over here how many aromatic protons do we have. We know from here we have 9 aromatic protons, so but we see here 11.4, so there are total 11 aromatic protons over here. So we have 9 proton plus 2 extra, that could be due to this NH. I have already mentioned about this NH. So we are again using the solvent CdCl3. So we may see this peak over here in this region, and also CdCl3 has solvent residual peak. We can see 0 and 1.1, and these are all CdCl3 peaks. So this corresponds to 9 aromatic protons plus NH plus CdCl3. But this compound also looks pure. So I will give more examples of impure NMR, some impure NMR, so that you can differentiate between a pure NMR and an impure NMR. Okay, so please do watch my previous videos to get the basic ideas how to predict an NMR signal and how to make an NMR signal, the different types of solvents we use, the solvent residual peaks, we analyze the chemical shift value of different functional groups. Please do watch my previous videos to learn the basics. Okay, so I'll continue my discussion on NMRs in my next videos. Please do like, share, and subscribe. And if you have any question, you can post them in the comment section. I'll try my best to answer them. Okay, so bye-bye for today.